Hello students, welcome back. In the last videos, we have done the examples on inverse function. Alright, so in this video also, we will be doing examples on inverse function. Alright, so let's see some more examples of different variety of inverse function. Let's see first example. Differentiate with respect to x cos inverse of 1 minus 1 minus x square upon 1 plus x square. Now, when we see this example, first of all, we should solve the bracket. So over here, something we have to substitute instead of x so that inside we should get one formula and afterwards we can apply the formula as cos inverse of cos theta. Okay, so let's see how we will be doing. So consider y equal to cos inverse of 1 minus x square upon 1 plus x square. Okay, so we will be substituting x equals to tan theta. So what is theta? Tan inverse of x. We can write theta equal to tan inverse of x. So when we substitute 1 minus tan square theta upon 1 plus tan square theta, what will be the formula? That is cos 2 theta. So y equal to cos inverse of 1 minus tan square theta upon 1 plus tan square theta will be cos 2 theta in terms of tan theta. So y equal to cos inverse of cos 2 theta. And what is cos inverse of cos x? It's x only. So y equal to 2 theta. But we have substituted, as I told you in before examples, that whenever we substitute as x equals to tan theta, we have to resubstitute the value of theta. So I have substituted y equal to 2 tan inverse of x. Now we will be differentiating with respect to x. So dy by dx equal to ddx of 2 tan inverse of x. As 2 is constant, so I can take it out. So derivative of tan inverse of x will be 1 upon 1 plus x square. So dy by dx will be 2 upon 1 plus x square. This is the answer. Now we'll move ahead. Next example. Differentiate with respect to x cot inverse of 1 minus root x upon 1 plus root x. Over here also we have to solve first bracket and then we have to differentiate. So over here also we will be requiring substitution. So consider y equal to cot inverse of 1 minus root x upon 1 plus root x. So we'll substitute root x equals to tan theta. So theta will be tan inverse of root x. Then y equal to cot inverse of 1 minus tan theta upon 1 plus tan theta. So I can write this as tan inverse. So plus minus will change. So I have written 1 plus tan theta upon 1 minus tan theta because we can write in form of tan inverse. Okay. Then numerator 1 I can write as tan pi by 4. Okay, so I can write this as tan inverse of tan pi by 4 plus tan theta upon 1 minus tan pi by 4 tan theta. Okay, so this is which type of formula? Tan inverse of a plus b. Tan inverse of a plus b is what? Tan a plus tan b upon 1 minus tan a tan b. So I can write this as tan inverse of tan of a plus b. Tan inverse of tan theta will be what? Theta only. So I can write this as pi by 4 plus theta. And what is the value of theta? It's tan inverse of root x. So y equal to pi by 4 plus tan inverse of root x. Okay, we have to resubstitute the value of theta over here. Now we will be differentiating. So differentiate with respect to x, dy by dx will be ddx of pi by 4 plus tan inverse of root x. Then derivative with respect to pi by 4 will be the derivative with respect to x, the constant will be 0, and derivative of tan inverse of root x will be 1 upon root x square and derivative of root x. Okay, so I can write this as 1 upon 1 plus x into 1 upon 2 root x. So I can write this dy by dx equal to 1 upon 2 root x in bracket 1 plus x. So this will be the answer. So like this we have to solve the example. Let's see some more example. Differentiate with respect to x cos inverse of e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. As I told you before, over here also we have to solve the bracket first. Okay, so first of all consider y equal to cos inverse of e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. So multiply and divide by e raised to x. So I have written y equal to cos inverse of e raised to x in bracket e raised to x minus e raised to minus x upon e raised to x in bracket e raised to x plus e raised to minus x. So applying e raised to x in bracket or opening the brackets, we will be getting e raised to 2x and minus e raised to minus x into e raised to x will be e raised to 0 and anything raised to 0 will be 1. So I can write this as y equal to cos inverse of e raised to 2x minus 1 upon e raised to 2x plus 1. Okay, so I will be taking minus sign out and I can write this in the form of y equal to cos inverse of minus of 1 minus e raised to 2x upon 1 plus e raised to 2x. Why I have written in this form? So that I can substitute e raised to x as tan theta. So y equal to cos inverse of minus 1 minus e raised to x square upon 1 plus e raised to x square. So substitute e raised to x is tan theta as I told you. So theta will be tan inverse of e raised to x. So just substituting y equal to cos inverse of minus 1 minus tan square theta upon 1 plus tan square theta. So this I can write as cos inverse of minus cos 2 theta and minus cos 2 theta I can write as cos inverse of cos pi minus 2 theta. Cos inverse of cos theta will be theta. So y equal to pi minus 2 theta. Okay, now we have to resubstitute the value of theta as tan inverse of e raised to x. Don't forget to resubstitute the value of theta. So y equal to pi minus 2 tan inverse of e raised to x. So we will be differentiating. So dy by dx will be ddx of pi minus 2 tan inverse of e raised to x. So derivative with respect to x, pi will be 0 and 2 ddx of tan inverse of e raised to x. So this will be 0 minus 2 upon 1 plus e raised to x square and again the derivative of e raised to x. Then again I will be writing minus 2 e raised to x upon 1 plus e raised to 2x. So this will be the answer. So these type of example in board they can ask for 4 marks. Okay, we'll see the next example. Differentiate with respect to x tan inverse of 2 root x upon 1 plus 3x. So how we will be doing this? Again, we have to solve the bracket first. So consider y equal to tan inverse of 2 root x upon 1 plus 3x. So 2 root x I can write as 3 root x minus root x. Why? Because in denominator I want 3x, and if you multiply it I will be getting 3x. 3 root x into root x will be 3x. So that is why I have written this as y equal to tan inverse of 3 root x minus root x upon 1 plus 3 root x into root x. So this is which type of formula? Tan inverse of x minus tan inverse of y. So I can write y equal to tan inverse of 3 root x minus tan inverse of root x. Now we will be differentiating. So differentiating with respect to x, dy by dx equal to ddx of tan inverse of 3 root x minus tan inverse of root x. Okay. So as we can apply subtraction in derivative, so I have bifurcated ddx of tan inverse of 3 root x minus ddx of tan inverse of root x. So this will be tan inverse of f of x. We will be applying the formula. So 1 upon 1 plus f of x square, again the derivative of f of x, composite function derivative. Then again tan inverse of root x will be 1 upon 1 plus root x square, again the derivative of root x. So in the next step, dy by dx will be 1 upon 1 plus 9x, because over here we have root square, so we will be writing x into 3 upon 2 root x minus 1 upon 1 plus x into 1 upon 2 root x, and 1 upon 2 root x I can take it out common, and I can write this as 3 upon 1 plus 9x minus 1 upon 1 plus x. So this will be the answer. Okay, I hope each and every student is getting the solution. Now we'll see the next example. Differentiate with respect to x, tan inverse of 5 minus x upon 6x square minus 5x minus 3. So as I told you, over here also we will be solving the bracket first. So we'll consider y equal to tan inverse of 5 minus x upon 6x square minus 5x minus 3. Okay, now minus 3 I can write as minus 4 plus 1. Okay, and then I need to take the factors of 6x square minus 5x minus 4, because this is the quadratic equation. Okay, and we can find out the factors. So how it will be? Y equal to tan inverse of factors will be 2x plus 1 and 3x minus 4. So I have written in the form numerator tan inverse of 2x plus 1 minus 3x minus 4 upon 1 plus 2x plus 1 into 3x minus 4. When you multiply these two, you will get this quadratic equation, 6x square minus 5x minus 4. Alright, and as you all know, which formula we can apply over here? Tan inverse of x minus y upon 1 plus xy. That will be y equal to tan inverse of x minus tan inverse of y. Okay, so we can write this as y equal to tan inverse of 2x plus 1 minus tan inverse of 3x minus 4. Now we have to differentiate. So differentiate with respect to x, we will be getting dy by dx equal to ddx of tan inverse of 2x plus 1 minus ddx of tan inverse of 3x minus 4. Again, we have to apply the formula of tan inverse of f of x. Over here also, tan inverse of f of x. So we will be writing 1 upon 1 plus 2x plus 1 whole square derivative of 2x plus 1 minus 1 upon 1 plus 3x minus 4 whole square, and again the derivative of 3x minus 4. Okay, so we will be getting derivative of 2x will be 2, and over here derivative of 3x will be 3, and I can write dy by dx equal to 2 upon 1 plus 2x plus 1 whole square minus 3 upon 1 plus 3x minus 4 whole square. So this will be the answer. Now you all can try the examples of exercise 1.2, 8, 9 and 10. Okay, and I am sure that each and every student is able to solve the examples of exercise 1.2, example number 8, 9 and 10. Okay children, thank you.